Okay, so yeah, I have a brainstorm topic for today. So I got started thinking about this because of the latest lunar lander that went. What is it called? Some cloud or something.
That made it in one piece.
Yes, that made it in one piece, and it's like there's now so many missions. You kind of have to think about, all right, what are the various ways you can differentiate? So I think we already found one differentiation, which is Anuraj's forecaster crypto type experiment, and also all the stuff we are doing with VPNs and stuff. That puts us in social robotics, so in groups of rovers. So I thought of two more ideas that we can maybe think about. So the oh, Anuraj dropped.
Yeah.
For him. I wonder if it's still recording. I can't see.
Yes. Well, it says live, so I'm guessing it's
Oh,
still
okay.
recording.
All right. So let's see. Can you see this Lego thing I'm holding up?
I can see. I'm just wondering if we should wait a minute and then he can
I'm just
cut
just
off the mission
camera.
time.
Yeah. Right. I don't know where I put my camera. If I had that, this would be better. Really should have. Whole work area has been a mess for months now.
Mm.
Too much travel. If I travel too much, the home front gets screwed up.
Yeah, I thought you were, what is it called? Dialing back on travel.
Yeah, it's been hard. I'm going to Asia again for 3 weeks in April. So yeah. Oh, you're back, Anuraj. Okay. Some glitch, huh? Okay.
So, Anuraj, we figured you'd cut off the time you weren't here from the recording.
He can't hear us, I think. Can you hear us, Anuraj? I don't think he can hear.
We can't hear you.
Can you hear me now?
Yeah.
Yes.
Now we can
Yeah,
hear.
I don't know. The PC rebooted randomly.
The more advanced computing work people do, the more this sort of thing happens. I only see like system crashing, rebooting when I'm like talking to like embedded people and hardcore systems level people. Normal people, nothing crashes. And okay, so yeah, just to recap what I was saying, yeah, so two differentiators I think we've found is one is something to do with crypto, and the second is if you have VPNs, you can do like troops of rovers, right? So I was thinking, are there other differentiations? And one I was thinking about was mechanical. So we've got like a few form factors already out there. There's very basic wheeled rovers, which aren't really rovers at all because they're like just cars with no special abilities. You've got the slightly more advanced wheeled vehicles, so rocker bogie type stuff. You've also got like the track tank like thing. He's rebooting again, I think.
Yeah.
It,
Yeah, but
yeah,
what do you mean that a wheeled vehicle is not a rover?
I mean it is, but if it doesn't have special abilities for rough terrain, it's effectively just like a regular paved road type of vehicle, and it's going to stall the minute you hit it with like a somewhat tough terrain to work on. So in that sense, it's like a limited roving capabilities, right? That's the whole reason you have like more special.
So
Uh,
what you're saying, a rover has to have um, Three Sigma, let's call it, mobility ability.
Something like that. Yeah, I mean, otherwise you could call like just a regular Tesla, you know, driverless car a rover, and in city roads maybe it is. Uh,
Yeah.
the Cybertruck keeps getting stuck in weird mud, and other trucks had to pull it. Have you seen that genre of meme? Cybertruck getting stuck somewhere in like
Yeah.
difficult terrain, and then some Ford F-150 or something comes and tows it out. So
Yeah.
that tells you very clearly that there is a difference between like ability to handle some terrains and not others. And also if you look at various kinds of construction vehicles, trucks that operate in like big mines, they're very different. Like a big mining truck, for example, its wheel is taller than most trucks. So
Yeah.
rowing, there is a mechanical kind of like angle that's different.
But an airplane, a helicopter, is that a rover? It can go anywhere.
Well, air is a whole different thing. But again, I think the key variable to think about is robustness. Like, are you trading off like versatile, robust ability to be in many conditions, so including stormy weather, strong wind conditions, things like that, versus are you optimizing for something like range or fuel efficiency or something like that? So I think the generalization of like all-terrain capability is robustness to just a lot of domain stuff. And Anuraj is back.
Yeah.
Yeah, I don't know. It's the CPU is hitting 100% and then it stops.
Do you have like some random runaway processes like Chrome tabs?
Ye-
Sometimes that happens to me. Chrome tabs that are running at like huge amounts of load.
So I just updated the NVIDIA broadcast thing I use. So let's see.
All right. This actually ties in well with the point I wanted to make with the reason for this mechanical brainstorm, because the smarter you make the mechanical part, the more you add complex sort of like failure modes, right? So yeah, we were talking, Mayor and I, while you were off, we were talking about, all right, why is just a regular car not a rover? And one reason is not do like very complex terrains, and that's why you need special suspensions. And so just a regular Tesla car is not a rover. The Tesla Cybertruck gets stuck in mud easily and other trucks have to pull it out. So rover as a mechanical thing. But I was thinking about what's the logic for why the Mars rover has that very simple passive mechanical differential. And you can think about like a more like complicated way of doing this, right? You can have like active suspensions with like motors and computer control and all kinds of like complicated things to do the same function, but they use like a very simple mechanical linkage stuff. And I was like, all right, that gives you passive higher traction capability and some sort of like platform leveling stuff. And can you even simplify it even further? So what's the simplest mechanical unit you could call like a rover? So I have seen like 8-wheel rocker bogies. I think there's some university that was doing it. So like the 6-wheel rocker bogie, but instead of a set of 4 wheels plus another set of 2 wheels in like a hierarchical configuration, it has 2 sets of 4 wheels with like a symmetric thing. And I was like, if you can do that, why can't you just make it 4 wheels? And that's this one that I mocked up. If you is the StreamYard my window, maybe you can make my window big, it'll be easier to see. Okay, yeah. So this is, I was trying to ask myself, what is the absolute simplest configuration of a passive suspension rocker bogie? And I was able to make this Lego 4-wheel rocker bogie fairly easily. So you can see it has the same basic mechanism. Where let's see if I can hold it correctly. So it's got this differential bar. You lift up one end, the other end, other side goes the other way, right? So this was my attempt at a 4-wheel rocker bogie, and I think this will do the trick. It won't be as high traction as a 6-wheeler, but it'll be better than fixed 4-wheel like a car, right? If you think about the reason this is useful is, one is the 2 wheels on each side move independently. So if one wheel goes over a rock, it's not that the other wheel gets lifted off as well, right? It stays on the ground. But this does a little more. Because the differential forces it to move in the other direction, it's actually planting the other side more firmly and giving it more friction and traction. So that's the logic of this mechanism. And actually, when I first did this mock-up, it struck me that this is actually similar to human walking. So this is actually like a hip joint. When legs move, you really do shift your weight from one leg to the other in a way that the foot that's on the ground has more pressure and traction. So if you pay attention to how you walk, you'll notice you do that. That's
but you notice how we do it. We do it by shifting our center of gravity.
Yes. This is
not by pushing further down.
We do a little bit of both. I haven't worked out the full biomechanics, but yeah, between shifting the center of gravity and some sort of like articulation, like this differential bar, we have like a hip differential motion. Okay, to finish the story, I was like, yeah, go ahead.
Why does the rover have the Mars rovers have 6 What's the advantage there?
I think it'll just give you better weight distribution and more probability that enough wheels will be not sticking
Okay.
that you can keep moving, right? Also, 6, I think, gives you a chance of like 3 and 3 tripod motion. So if you think about lots of insects have 6 legs, I think for similar reasons, which is that it gives you very stable tripod walking. At any given time, you can be on 3 legs, and that is like full stability. But I don't know if this is actually true of the 6-wheel rocker bogie. But the
Eh,
differential action, the differential action is not that different from this. It's just that one of the single wheels here becomes 2 wheels. So
Well,
Is there a system where there are two differentials? Like you could connect two of the and
yes,
have
that's
like
what I
a
was going to.
eight.
Yes, that's where I was going to next. I think the 4+4 configuration that I think we saw a couple of years back in one of our explorations, that must have 2 differentials, because otherwise I kind of don't see the point. But yes, you can obviously do that. You can make 2 of these 4-wheel ones and sort of connect them like a train. And that was one of the ideas I had. Like this could be a simple module. And if you have like several of these, they can link up in a train and form like a caterpillar type thing. But okay. The other one model I wanted to show you was I was thinking, can I simplify it even further? So this was my attempt at a 3-wheeler. So 3 wheels actually turns out to have some challenges. So first of all, it does kind of work. You can see that 2 of the wheels are in a differential arrangement. Is it clear that one is moving up and
Yeah.
the other is moving down? Okay. So these 2 wheels, they are connected by the same kind of differential bar over here. This center bar. So this is what you'll find on all these types of vehicles. But the problem is what to do with the 3rd wheel. So initially my thought was, can I actually somehow create like a moving back to the end of these forks? So these 2, you see the 2 things sticking out. I thought, can you add some kind of like articulated frame there and then suspend the 3rd wheel from a fork behind so that it's part of the same active suspension?
yeah, but does it go up or does it go down?
So here was my idea. So you have like 2 of these things sticking back, right? So there's 2 wheels here. Think of these as the 2 sides. It's hard to do this in the camera. Think of these as the 2 sides, my 2 hands. The loop is the wheel and the 2 sticks.
Yeah.
Parallel, right? So if you look from behind, when the differential is operating, you'll have them moving up and down, right? So this is basically the roll axis of the
You want the wheel to roll?
So I don't want the wheel to roll because that'll be kind of a useless motion.
But you want it to go up, but you want it to go down.
I wanted it to be the average of the 2 sides, basically. So the way I thought I could have it was I could connect a crossbar to those 2 members and have it basically move on the roll axis. So in an X kind of like movement, and somehow suspend the 3rd wheel in the middle of that thing so that it won't actually participate in the motion of the 2 sides as much, but you can modulate it. Like you can add a little vertical member and like make it get some of the motion.
Why do you need it to do anything? Once you have 2 wheels moving, the 3rd one is automatically positioned relative to the other 2.
It can't do any differential tractioning. So one reason I thought it could happen was if you have one wheel going up on a rock and the other wheel is sort of like pushing down like our feet, right? So that's getting some differential traction. Can you actually force the back also with extra pressure? So I wanted to.
That's exactly my question. If you're moving slowly, okay, if one wheel goes up, the center of gravity goes up and pushes the other wheel down even without a bogie.
Yes, so I'm trying to amplify the effect. Yes, so you can have a completely static chassis with like 3 wheels. One wheel goes up, it'll still put pressure on the other 2.
But you can't get more force because it's a passive system.
You can't get more force, but you can distribute what force you have differently. That's the point, right? So
what you're saying is that if one wheel went on a rock, you want to reduce the weight on that one wheel.
that may be the right thing to do. I think you'd have to look at the dynamics of a very specific situation to figure it out. But the more flexibility you have in like distributing the ultimately it's a passive system, right? So the gravity force down equal to the three normal reactions up, and the friction force is the friction coefficient times the
So
normal.
you
right?
need
Moment
either
as well. Yes.
the mover
So
to
it'll be
twist, which you
yes.
don't want, or you need it to move sideways.
Yes. So you will have the full 6 degree of freedom thing, right? You'll have three moments and three velocities. So yeah, you have to solve the equations. It's basic mechanics. But the point is, a passive but articulated mechanism, if it's clever, it might give you
No,
better
wait.
solutions. That's all it is.
Not what I'm saying.
Yeah.
I'm saying if you have 3 wheels and you take the weight off this one, the only way to do it is to move the weight sideways to the other wheel. Or
Yes.
you can actually tilt the thing even more, but then you're going to flip over.
Yes. So
Now,
your intuitions are correct, but this is an under constrained system, is my point. So depending on how the different things, if they're like articulated joints, how they're moving relative to each other, there's multiple solutions that are
absolutely. But I'm talking about overall. If
yeah.
you're reducing weight on one wheel, in order to increase it on the others, you have to move the center of gravity relative to the wheels.
Yeah, I mean that's basically what a articulated mechanism does. Anytime a moving joint moves, you've changed the shape and geometry of the thing, so the center of gravity will always move a little bit. So, yeah, that's
no. I'm saying it's the other way around. In order to get the effect that you want, which is to put more weight on one wheel, you have to move the center of gravity.
I mean
And
that's
you
what
might even have to tilt it. Okay,
this is not worth trying to solve by words. This is a math and geometry problem.
Good you say that. I asked ChatGPT.
Is there a three-way differential, or is it not possible? Like,
is there a what? Three-way differential? That's basically
like,
what I was trying to invent. I couldn't actually figure it out. Like, can you have a coupling between 3 points of support that'll actually act as a three-way differential? I couldn't figure it out. So what I ended up doing, to go back to this model, is I ended up suspending the third wheel relative to the main body chassis itself. So now it's basically the third wheel will not do anything very special. It'll be statically, rigidly coupled to the main chassis. It's not articulated with respect to anything else. So it'll
is this like mathematically analyzable, this differential mechanism?
Yeah, you can just load it up in any standard simulator and it should behave normally. It's this is all very straightforward classical mechanics.
Okay, so I agree with what you said about words, but I had to ask the chief engineer. And I asked him, why do you use 6 and not 4?
Ah, that's a good question to ask ChatGPT.
Okay.
Yes.
And a better stability, blah, blah, blah. So,
more degrees of freedom.
Why not 4? Just a second. So he says 4 wheels would be less stable.
Yeah, that
wheels allow for, I'm just telling you, lower center of gravity.
That's not quite the right answer. I mean, you're very obsessed with center of gravity. I don't know why.
I'm telling you what he says. I'm telling you what he says. Look at this part. When you climb.
I can't see. What are you sharing? I'm not seeing anything on the screen.
Oh, just a second. You got to see it.
How come?
I see it on the shared screen.
I see it. Huh. If you are on the StreamYard screen, you should see what Mayor is.
I'm seeing a black screen. I'm seeing something being shared, but it's a full black screen. I don't know what's going on.
Wait. How about now?
Nope.
Okay, this is interesting. How about now?
I see it. Yeah, now I see it. I don't know what the hell went on there.
Okay, so let's go back a second. So he says 4 boogie is not as good. Why? It's less stable.
Yeah,
But this is the more important part, number 2.
that's all. Yeah.
Okay? He says when you only have 2 wheels and you're climbing over a rock, you don't have a middle wheel to give you support. I think
Yeah. So the reason I was going to 4 wheels is actually to create the simplest stable module.
I am
Yeah.
not disagreeing. So I said, so why not 3 wheels? Might as well. So he thinks.
Yes, this is true. I found that the hard way. This guy is not the best design. It's beyond the stability problem. I should point out one more feature. I actually had to put in a mechanical stop here. You see this gray bar at the
Mhm.
bottom? That is there because this guy, if it goes up and down and that bar isn't there to stop it, it'll just flop. So I didn't realize that when I first built this, it kind of flopped. But that's kind of like, in a way, the feature, because if you go to the other extreme, what happens when you link a huge number of these 4-wheelers together? You basically get a caterpillar that can drape over the terrain very perfectly, right? So imagine like million
Um,
4-wheel bogies on like a very complex terrain. It's like a piece of cloth or rope draped over a landscape. That's kind of where I was headed with this. But
okay, so he says it's added weight, but I think the most interesting part about 3 wheels is number 3 here. Okay?
yeah,
He says it's not good for climbing. I don't know if it's true. It's what he's saying.
I think it probably is. So the one advantage of 3 wheels is, um, in one sense, it's always stable because any 3 points can form a triangle that can hit any
Yeah.
three, sort of like rough terrain, right? 4 means 3 will likely touch the ground, but the fourth in general is going to be off the ground if they're all on the same plane. So
Right.
3 is interesting because you can uh, sit on like a tripod on rough terrain. So
You,
that's one reason I was
you
interested in.
you just explained why 3 wheels don't need a rocker boogie. In 4, you have one in the ear. In 3, you never have one in the ear.
Now, you still could use a rocker boogie. So think a good example of a 3-wheeled system is actually a kangaroo. So kangaroos use their tails almost like legs, and their hip joint works like any other animal. So they do have like differential capacity in the 2 legs, and then they
Mhm.
use the third leg as basically a tripod type support. So I would say yes, you could still get value out of differential movement
So
in.
maybe you should try turning your 3-wheeler around, putting 2 wheels in front and 1 wheel in back.
I mean, I tried moving it both ways. That's just which way you're moving it. This doesn't have a natural orientation. I mean, yeah.
Call
But
it the kangaroo.
the kangaroo also doesn't if you cut off its head. The only reason we think there's a forward and a backward to a kangaroo is because it has a head facing one way, right? The geometry doesn't have like a preferred direction. Unlike gravity, there is a true up and down with any like land animal or vehicle. There is no true forward, backward, or left or right. That's a question of like arbitrary preferences. But yeah, the final one I haven't yet gotten to making is basically a 2-wheel differential. So this would be kind of like our tumbler rovers that we're making. So it would need to have like balancing logic on it, but it would still have a differential bar, so it could shift weight and like hopefully do more complicated things. And this one is kind of interesting because one of the Boston Dynamics robots is actually like that. Have you guys seen that? It's the 2-wheel bipedal thing that runs really fast and has
Yeah.
like a mix of wheel and stuff. I'll see if I can find a video. Uh,
Okay, I just want to point out that apparently people do have 3-wheel differentials.
oh, they do. Okay, I should have Googled before trying to invent my own.
I didn't Google. I'm hallucinating. I mean, why? What do I care what the people actually did? So he says usually they do electronic, but there's also a planetary gear differential for 3-wheeled robots.
Uh, Hold on, I think this is worth taking a quick look at if it's the right video, the Boston Dynamics one.
Pinion gear electric.
Hold on, I'll just share the YouTube link. Give me a second. For some reason, I'm having problems with StreamYard today. That's the Boston Dynamics one I was talking about. But yeah, I think 2 is not that interesting because active balancing is a good stunt. But 4 is, I think, so my conclusion from my experiments is that 4 wheels would probably be the right unit for a modular passive differential type rover system, because you don't have like the failure points of like smart electronics and trying to too much control. You can like balance, you can do some differential traction. It's basically a Caterpillar module, so you can link multiple of them with like an articulated joint. They can go over mountains. So I might try to do some more experiments. If I have enough parts, I'll build a multi-Lego train of these 4-wheelers and see where that goes.
Okay, I'm showing 2 links, and people have done work on 3-wheeled robots, perhaps.
Yeah, they probably have. Capture. Oh, yeah.
Look in the upper right corner.
Yeah.
Okay, and the paper is on an actual 3-wheeled omnidirectional robot.
Oh, you have to be careful. People use the word differential in 2 ways. So one is simply controlling them separately and independently. So if you run the 2 motors differently, that's also called differential control. Whereas differential in a mechanical sense is like some sort of like mechanical thing. Yeah.
ChatGPT doesn't agree with you. ChatGPT believes that having electronic differentials is a type of differential.
Yeah, it solves the same problem, but they're 2 different senses of the word. They might solve the same problem, but I'm just pointing out that they're different.
Not a mechanical.
Yeah.
No, but the mechanical one solves it in one more z-axis, right?
I mean, they're kind of equal. You can solve it electronically. Anything you can do mechanically, you can solve electronically. There are even electronic gearboxes. So yes, you can sort of like simulate and replicate any mechanical function. The advantage of doing it with a mechanical thing is, of course, robustness and, in some cases, trade-off of simplicity. It's not always simpler. Like traditional automotive differential, you guys have seen that, right? I might have a model here somewhere.
Yeah.
It just distributes the. But yeah, every gasoline engine car has a traditional differential in the rear axis. That's why, like, when one wheel gets stuck in the mud, the other wheel does not also get stuck. It's a fairly complex assembly of like 4 bevel gears, prone to failure, lots of lubrication problems and stuff. But yeah, that's a differential that solves a different kind of problem. But yeah. Anyway, so I think this is to go back to my earlier point. I think having an interesting mechanical differentiation is worth thinking about, because if not, if there is no differentiated ideas we have about the mechanical body, then the correct solution is get out of the mechanical part altogether and buy off-the-shelf robots from China or whatever, and focus entirely on the software and AI part. So that's possible roadmap direction. And I like playing with mechanical parts, so I'm
That's
expecting.
enough reason to do it. Remember, it doesn't have to be better in everything. It just has to be better in something.
Yeah. So, but I don't like just wasting time on toy side explorations. I do like thinking about the problem of, is there a reason to like differentiate mechanically? Like, are there unexplored spaces of mechanical design space that are worth exploring? So the big $1 billion Mars rovers, they went the 6-wheel whatever direction for a reason. All the cheap missions going to the moon right now, they tend to be much simpler. They're like 4-wheelers and things like that. The sidewalk pizza delivery type robots, they would be almost anti-rovers. Like almost anything stops them. They're like very small wheels, very low to the ground. Small obstacles will stop them. If they run into a snowdrift, they have to ask humans for help. But that's a different problem, right? They're solving for the urban environment. Okay, so that was one discussion topic I had. The other discussion.
I don't think we're done with that discussion topic yet.
But let me introduce the other topic because it's related. The two topics, the reason I wanted to discuss them together is, let's see, this one. So we've been kind of assuming that the environment we're building for is kind of a wilderness environment. But I'm thinking one of the things that'll happen both on Earth and Mars and Moon is future rovers are more likely to be in complicated and extreme environments, but not necessarily wild, as in they have an element of design in them. So the example I've been thinking the most about, mainly because I have that huge pile of cardboard tubes we talked about once. I got them for free from somewhere. And I was thinking, what art project can I make with it? And the basic idea I had was, so these are like 4-foot long cardboard tubes with about 8 inches diameter, so fairly substantial. And I have like about 25 of these tubes, and we can build like a network of tunnel-like things. And I was thinking, all right, that's actually one very likely kind of design for like, Mars bases or something. If you want like a habitable environment where it's easy to seal in air or whatever, you might want to dig a system of tunnels underground. But that's an example of what I mean by archaeology. So instead of designing a rover for like, say, the Mojave Desert or like a general rocks and small hills kind of environment, can we think of like other rovers? And to connect to the previous topic, are some mechanical designs more suited for some environment designs than others? Like, a system of tunnels, and you want a set of rovers that can wander the system of tunnels. You want it to have maybe like canted wheels that are at an angle, so it can be on the sides of the tube walls and it can move that way. Maybe you want it in a way where one wheel is on top and it's moving vertically, almost like an elevator, right? So designing a rover for a tube environment is interestingly different. So that's the reason I was thinking about it. But yeah, this page,
at least on the moon, there could be a lot of tunnels because it doesn't have an atmosphere, right?
Yeah.
So it might be or it might happen that like everything on the moon is like underground.
Yeah, I suspect for a lot of reasons it will be underground because you've got extreme radiation that needs protection. You've got water that you want to prevent from evaporating. Lots of reasons to build underground, basically. And
in tunnels, like if it's one way or two way, the rover will have a different, because if they have to pass each other in the same tunnel, then you need a different mechanism.
And you can have things like this is going on the tunnel, but if it's the right kind with suspension ability, it can go and travel on the ceiling, maybe.
Yeah, but there's an important question here. Robots that travel in tubes are well known. Pipes.
Sewage inspection type robots, yes.
Exactly, oil pipes, more like it. But that's exactly the point. Sewer versus oil versus what you're showing here in the picture, but let's say underground mining tunnels.
Yeah.
If the rover's small, what does it care that it's inside a tunnel? The ground is the same ground. So what difference does it make that the rover's inside an archaeology?
It might have things it can take advantage of in the environment, is my point. So if the tube is of a particular diameter, the ceiling might be low enough that it can actually use the ceiling for mobility, which would involve like putting wheels in odd places. So many things actually that do go into tubes, they tend to have like, think of a triangle with a wheel at each vertex, but the direction of motion is perpendicular to the plane of the triangle. So that's one way you could have like a rover that moves inside a pipe. It
But,
can
but we're
rotate.
not talking about pipes. We're talking about 4 meter diameter pipes, right?
You can build a 4 meter diameter rover.
But are you planning on having a rover that shares a space with the people, like
Yeah, so
that
the
size?
center could be a completely empty circle. So it's almost like a door frame that travels in. So there's lots of like interesting possibilities like that.
Why would that be good? I'm with you. Why would that be good? It means you can't do anything on the walls. You can't hang pictures.
It's just an interesting idea to me. You can
No,
make it simple.
I'm going with you.
Yeah, yeah. Uh, I think the broader point I'm making here is: are there interesting environmental sort of architectures that suggest interesting
Yes.
mechanical rovers, not just on a tunnel? So tunnels are the simplest one I could think of. But think about climate change and extreme weather, and chances are like our own built environment on Earth is going to have like more complex arcology type
We,
features. Like this
we,
one that I showed is basically the Saudi Arabian one that they kind of gave up.
Neil,
Yeah, the Neom one. I think it's a ridiculous conceit of like a rich dictator, but it's still kind of fun to think about. Like this would
Oh,
be a great environment for.
it's like a single line or something, right?
Yeah, yeah.
But I think they have reduced the length. Uh,
It went from 100 miles to 1 mile now, I think. But I
no,
think
they started with 1 mile. You know, we're still hoping for 100 miles. They don't have enough people to fill up the
yeah,
whole thing.
I mean, it's the Saudi desert is a slightly ridiculous place to try and build this, but hey, he's got billions to burn. But yeah, I don't know if there's,
No, he doesn't. He doesn't.
or he's trying to get billions from other people. SoftBank, I think, is or he's an investor in SoftBank. Yeah, if you do Google image search on arcology, lots and lots of very interesting pictures come up. Hey, here's an interesting
what
one.
is archaeology?
It's a term coined by an Italian architect for basically a very dense and closed environment designed together. And now people use it mainly for like futuristic cities on Earth, but also they use it for like space stations and things like that. So that TV
Kind
show
of
really expand.
Atlantis,
Yeah.
like Atlantis under the sea, right?
Yeah, that would be another kind of arcology where the
Okay, yeah.
extreme environment is waters. There's an interesting one. Parts of Singapore actually look like this. So Singapore has now multiple
They're like,
buildings.
which one? Which one?
Hmm?
Which one do they look like?
The Marina Bay Sands has a thing on top that looks like this, but there's several buildings. This was a architectural style that the government was promoting for a decade or so. So if you walk around Singapore, you'll see multiple buildings, not this extreme, but where the 10th floor randomly is somewhat open and is a garden. There's
Yeah.
like trees and creepers all over it.
So they have that green building in Milano, which is also
You can also think of like ancient cities. Like I would say Venice actually is kind of an arcology because it's an extreme city that could not actually exist in most places. It needs very special engineering to survive the water. Another one is Vegas. So Vegas is in the middle of the desert, and a lot of the features are almost space station like. Like it has a huge underground storm drain system. So I once went with a friend and explored it. It was really kind of fun. Okay, sorry, I was looking at the wrong tab. I meant to share this one. Yeah, this is the one I was showing of a Singapore like thing. Extremes. This is extreme Singapore basically. Let's see if there's any other interesting ones worth looking at. So some of these I think are like good idea or thought starters for like habitats on other planets, or even if not habitats, like even if you're just doing like more extensive exploration and terraforming, you would have systems like this.
So what you're really saying is if we build a rover suitable for one of these arcologies, it has a limited number yet diverse types of terrain that you have to go through. So instead of having a rover that's good, for any weird terrain, it has to be good for rugs, plinths, and walls. I'm
Yeah.
maybe exaggerating. So yeah, and the good news is that many arcologies you have to have many different designs.
Yes.
But none of them have 3 wheels.
3 wheels is kind of just an abstract engineering challenge.
Yeah, yeah. Joking.
Were you guys in that session? We did something a couple of years ago where we were doing a rover day or something. I think one of the sessions I was in, we were doing, actually, I did this in one of our own meetings as well. Rovers designed for kitchen environments, right? So kitchens, if you want a useful robot that can operate in a kitchen, one solution is to have like 2 arms suspended over the kitchen counter that can do chopping and things like that, which there are some startups doing that kind of thing. I was more interested in something that looks like a Roomba. So it's like a floor level moving robot, but it has like a tall dimension to it that's at least cabinet height, so it can walk around pulling open drawers or maybe pulling itself up on a counter and going high. So traveling in the vertical dimension, taking advantage of a kitchen's vertical surfaces, handles, grooves, things like that. So that's a kind of like a very simple arcology, right? A kitchen environment. Like it's actually quite challenging to design a rover that can move in a kitchen as flexibly as a human can.
Well, it's actually more challenging to have it deal with the counter. The floor is usually, clear, but the counter has an apple, a knife, a cutting board, a hot pot, a rag.
I would actually think the spider is a good form factor for a kitchen, right? Because it can climb, it can walk, it can like straddle an apple on a counter. So yeah, your
counter. The counter is like 60 centimeters deep or 50 centimeters deep. It doesn't give you a lot of room if you're going to walk around on the counter.
How big is your hexapod? Oh, you have it handy.
Just a second.
Okay, yeah, that's way too big for a typical kitchen counter. But if it's scaled down a little bit, that's another reason I was.
Yeah, but you wanted to be able to step over an apple.
Yeah, so you have to like pick off some dimension. So a typical cutting board is about A4 size, and I think if you have 6 inches clearance above that, that's a useful form factor.
We saw some harvester robots for agricultural use with very long, thin legs.
Yeah.
I wouldn't do 6 legs though. I would do more because you don't know if you have where to put it down.
Yeah, so I'll probably want to go down this bunny trail a little bit more. I'm thinking a good starter experiment in co-designing rovers and arcologies is to think in terms of tubes and tube rovers. So 4-wheel or something simple like that that's modular and can link up and form trains. And can navigate tubes in some sense. So at least as a thought experiment, it's worth working out.
But will it be 3D printable? So like others could also.
I think so. I mean, the cardboard tubes are standard size mailing tubes anybody can buy, so that it's easy to construct, and PVC pipes, lots of easy tubes are one of the easiest construction materials to find. And I think, yeah, you can, like, this would fit in the tubes I have. It's just about the right size. So, 8-inch tube is actually quite a lot of room to play around with. It does constrain you strongly into one dimension, though. So that's a challenge in itself. Like you have to go around things, people trying to use the tube. Like imagine a space station that's fully tubular. There's no gravity, so you can run on any side, but you have to find a way to anchor yourself there. But everybody has to live in that one dimension, so it's worse than flatland. It's line land.
I'm just wondering if the Lego has parts which are suitable for touching the tube.
What do you mean touching?
You know, the tube is a little bit curved. The wheel is
Oh,
flat
yeah,
on the
that's
bottom.
doable. There are like uh, friction hinges that can be positioned at any angle. So I have some of those parts, and there's also angled rods and stuff. So that's not hard. Creating
No,
those,
no, no, no. The tube itself is curved. The
yes.
wheel is flat,
Oh, okay, yeah.
so it
That's
doesn't touch well.
so that shouldn't be too hard. If the curvature is not too bad, it should be fine. Or we can 3D print wheels that match the curvature. But that would seem like a little bit over optimization to me. I would rather do thin enough wheels that the curvature isn't a problem.
Okay.
And yeah, this is mainly a design exercise. But the more general sort of like default rover domain of like rocks and wilderness, um, even for that, I think it's interesting to consider a four-wheel rocker bogie or like trains of four-wheel modules, caterpillars basically. So modular caterpillar rover would be an interesting thing to try.
I'd love to do one that can walk on the top of the tube.
Yeah,
You know, maybe with little sticky pads.
I would do kind of like a claw-like thing that hangs onto a rail,
Hmm.
Yeah, but
or like
that requires a change in the
But
tube.
doesn't this some of these metros already do that? Like the hanging metros, they kind of hang on rails and go around the city.
I haven't seen
Okay.
metros like that. I've seen cable cars, if that's what you mean.
No, no, I think there are like I've seen those. Instead of like going on top, they hang on the rails.
I've only seen electrical
Okay,
power supplied from overhead, so I don't know what you're talking about. But yeah, if you've seen that, that's an interesting example.
Okay, so here somebody built a robotic caterpillar which can walk upside down.
yeah, it's called a suspension railway, and there is a wiki page on it.
The captchas are getting worse and worse.
Mm.
Caterpillar. Okay, yeah. So one of the constraints I think is important if you're thinking of other planets and stuff is you should not use mechanisms that rely on compliance, so materials being soft or sticky and things like that, because those properties change drastically with temperature, pressure, and stuff like that. Which is one of the original reasons, by the way, I think the Mars rover has the bar-based differential as opposed to like gears which need lubrication and things like that. So I've seen gecko robots that try to like copy lizard uh, hands. So they have like sucker cup type things. They can climb up glass doors and stuff. So under normal temperature, pressure, kind of like conditions, you have a lot more options on mechanisms you can use.
Oh, okay. So here's a robot that is actually designed to walk on branches. Upside down as well.
Oh yeah, that's nice. This one looks pneumatic.
It is.
So yeah, this general design direction, but made with like rigid high environment range parts. The Have you guys seen? No, you haven't been to Seattle, but Seattle has a monorail,
Yeah.
and it's,
Disneyland does too, doesn't it?
where else?
Disneyland.
Oh yeah, Disneyland has one too. I think it's the similar kind. But the interesting thing about that is the wheels of the monorail. Let's see if I can find a good diagram here.
Oh, it's not maglev?
No, it's not maglev. It's 1960s. It's very primitive technology, but the wheels are kind of interesting. It's got three. Okay, let me share here. I don't know if you can see the details, but it basically wraps around a square cross-section beam. So one set of wheels is in a normal orientation downwards towards gravity, but then you
Yeah.
have four sets of
Like
wheels.
like an elevator.
Kind of, yeah. So this is basically a horizontal elevator in many ways. So this is, I think this solution would work for upside down as well. So something like this, you just have to like design the geometry slightly different.
Yeah, but then you're having the side of the wheel carry the weight of
Yeah.
the robot. You don't want that. It makes much more sense for you to have angled wheels
You
inside
run
a
all the way
tube.
around, so kind of like a cable car. So you put the wheels, it'd go
No,
all the way.
I have a groove, a rounded groove, and I have the wheels inside. So the weight goes, towards the axis of the wheels.
That's fair enough. Yeah. Here, the side wheels are, I think, smaller than the main wheels. This is not actually a very good diagram. Ah, here we go. Here's, I don't know if this is much better. This is an engineering drawing. This is, yeah. Each time I write it, which is not very often these days, God, I hate these cookie things. I try to peek under and see what it looks like. Yeah, this is fairly
So
clear.
it's what, hanging on some cushion, or
There's no cushioning or anything. It's a regular wheeled vehicle. It's not upside down. It's a regular side up, but it
okay.
just looks cool. And then for 1960s, it looked futuristic. But yeah, now a more typical way to do a monorail would be a maglev system, not mechanical wheels. And yeah, it has two wheels on top that are slightly broader and larger, and then the four side wheels are basically stabilizers. Oh wait, I'm not sharing this at all. I keep sharing the wrong. Okay, yeah, this is the picture. Should be clear here what's going on. Yeah, straddle running gear, that's what they call it. But yeah, this sort of thinking is what we have to do if we start thinking in terms of rovers for arcologies and rovers for zero gravity. That's actually an interesting problem. Space stations are more likely than, I think, planetary bases. Then you can ask, if you have a very large and sort of like open architecture space station, then how do you like wander around on it? If you look at the current space station, it's actually quite interesting. It's padded all around. There's lots of hand grips everywhere, and the astronauts move around like monkeys. So moving within like zero gravity in a tube environment is.
Wait, I can't build a setup in my living room.
We can come close somewhat.
Zero gravity?
Not zero gravity, but if you build a robot that can go down vertical and horizontal tubes, I think you'll start to approximate the conditions, because you're like making it move against gravity in all directions. So here's a simple, interesting challenge. You have a system of tubes where some tubes are vertical and some are horizontal, and you want a rover that can go down both kinds of tubes. So in the vertical tubes, it'll act a little bit like an elevator, and in the horizontal tubes, it'll act like either a rover or an upside down rover.
How does it, go 90-degree angles.
Yeah, or maybe it doesn't reorient at all. Maybe it has different set of wheels that it uses for the two configurations or two directions. Anyway, that's all I had.
Yeah, we have 3 minutes left. But I think we can end today.
All right.
Okay.
All right. Hopefully, I'll be able to build or prototype some of this in Lego, at least, if not in 3D printed forms. But yeah, I will try to make some CAD mock-ups of some of these things.
Okay.
All right. See you guys.
Yes, yes.
Bye.